So the group of rational and irrational numbers are real numbers. Okay. Rational numbers. What is meant by rational number? The number which we can write form P by Q form where P and Q are integers and Q not equal to 0. Okay. This is rational numbers. Then what is irrational numbers? Irrational numbers which we cannot write in the form of P by Q form. Okay. Leave it rational and irrational. Okay, how can I identify a rational and irrational number? That we need to learn first. So the concept is very important. After that, we can understand we can learn the definition and all. So I'm going to keep here rational and irrational. So leave it that rational and irrational. So we can come back to the point. Real numbers. We don't know rational and irrational. We know what is that? Decimal numbers and non-decimal numbers. We have only two types of numbers. What is that? Decimal number, non-decimal number. So we can go to the non-decimal part. Non-decimals. What are the non-decimals? You know all the negative numbers, 0, positive numbers. This all are called what? Non-decimal numbers. These category -3, -2, -1, 0, 1, 2, 3. These all are called integers. Okay. If you are taking 0 to the positive numbers. Okay. So I have written here 0, 1, 2, 3, etc. Okay. What is that? Whole numbers. So 0, I am going to throw it out. Then the remaining 1, 2, 3. We know 1, 2, 3 are counting numbers and we are using this for counting. So these numbers are called natural numbers. So now look at this. These category are called non-decimal number, decimal numbers. Decimal numbers are two types. Non-terminating and terminating. What is meant by terminating? Terminate means end. Okay. Now non-terminating numbers, terminating number. Here no end, here it has end. There are two types of non-terminating numbers. One is non-recurring numbers, another one recurring numbers. Look at this. Decimal numbers. Decimal numbers are two types. Terminating and non-terminating, and non-terminating are two types, non-recurring and recurring. Okay, look at this. Terminating number. Here I am going to write some examples. 1.5. Yeah, we know 1.5. After the decimal, the next digit is 5. And is there any continuation for that? No continuation. So we can write 1. Example of terminating decimal number. Another example, 3.25. 3.25. See, look at that. 3 after 3, the decimal. After decimal, we have the digits 25. It's a terminating decimal number. For example, I will show you one fraction 5 upon 2. Okay, 5 divided by 2. We know whenever 5 dividing by 2, we will get 2 2s are 4. The remainder 1 decimal 10. 5 2s are 10. Okay, so the result is 2.5. It is terminating decimal. Okay, every fraction we can rewrite as decimals. Now non-terminating numbers. Look at the non-terminating numbers. There are two types, non-recurring and recurring. What is meant by recurring? Sometime while dividing, okay, I will write one example. 10 divided by 3. Okay, 10 divided by 3. We know 3 3s are 9. The remainder is 1. We can keep here again 3 3s are 9. The remainder is 1. If it will repeat in this way, 3 3 3 3 3 3 is going. So 3.3333333. It is called recurring, non-terminating. It is not terminating, but it is recurring. It is repeating. So recurring, repeating. It is repeating. Okay. Okay. Now look at this, rational numbers. Okay, we can go to the definition of rational numbers. What is the definition of rational number? The number which we can write in the form of P upon Q. Okay, P by Q form where P and Q are integers and Q not equal to 0. So now we can come back to the non-decimal numbers. These all non-decimal numbers are rational numbers. These all decimal numbers, non-decimal numbers are rational numbers. Why? We know -3. Okay. So take the -3 and we can write as -3 divided by 1. -3 by 1. It is P by Q form. Yes. And you take any other integer. Okay. If you take 100, -100. So this we can rewrite as -100 upon 100 by 1. So it is a rational number. So these are all the non-decimal numbers we can write in the form of P by Q. So it is rational numbers. Is it clear? These all are rational numbers. Okay, now we can come back to this. Now we have another one category, decimal numbers. Okay, and decimal numbers we have a two category, non-terminating and terminating. So first we can go to this terminating number. For example, I am writing 3.5. Can I write 3.5 35 upon 10? Yes, it is. We can write in the form of P by Q. So this is also rational numbers. One more example, 3.25. Is it a terminating number? Yes, it is terminating number. This we can rewrite 325 upon 100. This also P upon Q form. So this we can call rational numbers. Now we have another one category. What is that? Non-terminating numbers. In this non-terminating numbers, there are two types of numbers are there: non-recurring and recurring. We can see non-terminating and recurring first. Non-terminating and recurring. Look at this 3.3333. Already we know 3.333. What is that? 10 by 3. So no, 10 by 3. Non-terminating and recurring numbers, definitely we can rewrite as P upon Q form. This is also rational numbers. Okay, next we can check this category. Decimal number, non-terminating, non-recurring decimal numbers. 3.2567 1 2 3 4 6 7 etc. It's going on. So these type of numbers we cannot write in the form of P by Q form. Okay, so these type of numbers are non-terminating numbers. For example, decimal expansion of root 2. Okay, root 2, if you find the value, that will be a non-terminating, non-recurring decimals. Root 3. See, it is not a perfect square number, but it is under square root. The result will be non-terminating and non-recurring numbers. Now look at this. So we categorized decimal and non-decimal numbers and we learned. And now tell me rational numbers and irrational numbers. What are the rational numbers? All the integers are rational numbers, all the whole numbers are rational numbers, all the natural numbers are rational numbers, all the terminating decimal numbers are rational numbers, all the non-terminating recurring decimal numbers also rational numbers. Then what is irrational numbers? Non-terminating, non-recurring decimal numbers are irrational numbers. Now we know there are infinitely many rational numbers in between two rational numbers. Shall we find four rational numbers in between 3 and 4? We have two methods which is easy that you can follow. Okay, method 1, mean method. Okay, first we need to find the mean of 3 and 4. 3 plus 4 by 2, that is 7 by 2. So 7 by 2 is, we know 7 by 2 is 7 by 2 equal to 3.5. It is exactly in between 3 and 4. So now if you want, you can write 3 comma 7 by 2 comma 4. Okay, so now again we have to repeat the process. Mean of first two, 3 plus 7 by 2 by 2. Okay, by 1. So now we know the process. Here 6 plus 7 by 2 and the reciprocal, this will be 2 by 1 and it will go 1 upon 2, then it is 13 by 4. Now again we can rewrite this result 3 comma, what is the number? 13 by 4 comma 7 by 2 comma 4. Again if you repeat the same step, 3 plus 13 by 4 by 2, that we can rewrite 4 3 is 12 plus 13 by 4 into 1 upon 2. It will be 25 upon 8. So this 25 by 8. Now these are the numbers 3, 13 by 4, sorry 3. Now these are the numbers 3, 25 by 8, 13 by 4, 7 by 2 and 4. Again we need one more number, so we can find the same method. 3 plus 25 by 8 by 2, this is equal to 24 plus 25 by 8 into 1 by 2. So answer is 49 by 8, 1 up by 2, that is 49 by 16. So these are the answers: 7 by 2, 13 by 4, next 25 by 8, the fourth one is 49 by 16. This is mean method, method 1. First we are finding the mean of the two numbers, and next any two numbers you can do it. Okay, 3 by 3 and 7 by 2 have taken. If you want, you can take it 7 by 2 and 4. You will get another one answer. Okay, and we have another one method, 3 and 4. In between, how many rational number we need to find out? 4 rational number we need to find out. So first we have to add 4 plus 1. The result will be 5. And next we need to write 3. 3 equal to, already I told you, 3 we can rewrite as p by q form, 3 by 1. Now it is a fraction. This fraction, numerator and denominator, we are going to multiply with this number, 5 by 5. So this will be 15 by 5. And the next number 4 also we can rewrite as 4 by 1, and this we have to multiply 5 and 5. The result is 420 by 5. So now look at this, 15 by 5 and 20 by 5. How many numbers are in between that? 16 by 5, 17 by 5, 18 by 5 and 19 by 5. We have 4 rational numbers in between 4 and 3 and 4. Okay. Exercise number 1.1, question number 1. Is 0 a rational number? Can you write 0 in p by q form? Yes, 0 is a rational number, and 0 we can write as 0 by 1 or 0 by 2 or 0 by 3 or 0 by any negative number, 0 by minus 5, anything we can write. Okay, this we can rewrite as in the form of p by q. Now question number 4. Okay, first one. Every natural number is a whole number. Yes, every natural number is a whole number, because whole numbers contain all the natural numbers. Whole numbers, what are the whole numbers? 0, 1, 2, 3, etc. etc. See, these are natural numbers, 1, 2, 3. It contain in whole numbers. So, yes, every whole numbers are natural numbers, because whole number contain all the natural numbers. Next one, every integer is a whole number. Every integer is a whole number. Every integer is a whole number. No, every integer is not a whole number. We know negative numbers are not a whole numbers. So because negative numbers are not a whole numbers, if you want to write example also, minus 2 is not a whole number, minus 3 is not a whole number. Third one, every rational number is a whole number. Every rational number is not a whole number. We know that. So no, because rational numbers contain decimals, negative numbers, all the p by q forms. These type of numbers are not whole numbers. So we can say, next question number 3, find 5 rational numbers in between 3 by 5 and 4 by 5. We know 3 by 5 and 4 by 5 are like fractions. Denominators are equal. So it is very easy. Now look at this, 5 rational number, the same process, 5 plus 1, which is equal to 6. Now here writing the first fraction, 3 by 5. Okay. Here the 6 is the value, so we can multiply numerator and denominator by 6, which is equal to 3 6 are 18 by 5 6 are 30, and the next number 4 by 5 is multiplied by the same number 6 and 6, which is equal to 4 6 are 24 and 5 6 are 30. Now we know in between that we have 19 by 30, 20 by 30, 21 by 30, 22 by 30, 23 by 30. Okay, 1, 2, 3, 4, 5. 5 rational numbers in between 3 by 5 and 4 by 5. This is the process. Here we can solve one extra question. Find 5 rational numbers between 2 by 3 and 3 by 4. This is unlike fraction. So no, unlike fractions. Okay. Here, first we have to take that fraction 3 by 4, 2 by 3 and 3 by 4, and the denominator's LCM of 3 and 4, which is equal to 12. Now we need to make it as a like fraction. We know 2 by 3, 3 we need to make it as 12. So we have to multiply with 4, 3 4s are 12. So whenever we are multiplying some value with the denominator, the same value we have to multiply with numerator for balancing that. 2 4s are 8 by 12, and the next one 3 by 4. We know 4, how can you convert as 12? 4 3s are 12. So the same I am repeating for numerator also. 3 3s are 9 by 12. Now we have the fractions. What is that? 8 by 12 and 9 by 12. We know these two are equivalent fraction. 2 by 3 equal to 8 by 12 and 3 by 4 equal to 9 by 12. Next we have to find out 5 rational number. As usual process you can do 5 plus 1. No problem, we will get the answer. 5 plus 1 6. Now we can write 8 by 12 into 6, and here 6. 8 6 are 48. 12 6 are 72, and here 9 by 12 multiplied by 6 and 6. 9 6 are 54 and 12 6 are 72. Now we can see in between 48 by 72 and 50 by 72 we have 49 by 72, 50 by 72, 51 by 72, 52 by 72, 53 by 72. We have 1, 2, 3, 5 numbers, rational numbers in between 2 by 3 and 3 by 4. Okay. If it is a like fraction, we can do directly 5 plus 1 and multiply. If it is unlike fraction, you have to find LCM and follow this procedure and solve it. You will get the answer.